Recording. Okay, welcome to Friday of week 1, short days on Fridays. I'm not going to do any announcements except to tell you that next week we are going to go to the study skills section and talk about how to write answers in a step-by-step way, the way math people want you to write them, and how to take good math notes, which is different than how to take notes in other topics. So if you are a very visual person, then sometime before Monday's class, read those for yourselves. And if you're just someone that likes to hear someone talk at you and be auditory, then you don't have to. But just a heads up, we sort of focused on how to do homework this week, but we're going to talk about how to write things next week. Okay, one last call. Any rounding problems people want me to do on the board? We haven't finished fractions, but are there any of the fractions problems for things we've talked about in class that you want me to do more like that? No. Okay. So since there weren't any questions about rounding and we finished that topic, that will now be due in a week, right? So a week from today, if you haven't turned in your rounding code, then you'll want to do that. By the way, turning things in on time isn't your last chance to do it. When you look here, then it's a class participation thing to turn in half or all the homework on time. So if you or your kids or your parents get sick and your homework isn't on time, don't give up. Turn it in when you can. You just won't get that star. You'll still get the homework done. So. Okay, we left off. Let me make this bigger. Maybe even bigger. Okay. Talking about how to go back and forth between decimals and fractions. We're going to talk more about that, although it's pretty quick, and talk about ratios and rates. And I'm not sure how far in the percent thing we'll get today. It is a short thing. But we'll probably, for sure, finish fractions and then get a little bit into percent before we have to stop. You know the routine. When we finish fractions, then start doing the homework on that. Look at the things in our notes. Look at the textbook problems. Do a bunch of odd-numbered textbooks until you're feeling like you're on top of things. Use the textbook examples problems to complement what we do in class. And when the textbook is going nice and smoothly, maybe try one of the random ones to see if you're good at those too. And then as the icing on the cake, turn in your code. So same routine. Okay. Our goal is to eventually be able to move between a number as a decimal or as a percent or as a fraction, however we want. And even more than that, we want to, if you were taking Math 60, just be able to look at a number. And if somebody writes 0.08 on the board as they're lecturing in a Math 60 class, then you want to think about that as 0.08 and 800ths and 8% all at once, so that whatever is the most useful in that situation, you're ready to go. That probably won't happen in Math 20. We're not going to expect you to sort of have all three pop into your brain simultaneously. But eventually that's the goal if you're going into Math 60. So the first thing to do is just move back and forth between the decimals and the fractions. We did these at the very end of class on Wednesday, so I'm going to pick two more to do as our examples this time. Actually, let's do the process for turning a decimal into a fraction was just to say the decimal's formal name. Pretend you're a stenographer in a court of law and taking down someone's dictation. And when somebody puts 0.6 on the board, you're going to not say 0.6 in what you're typing, but you're going to call it 6/10 because that's its formal name when it wears a tuxedo and goes to visit a wedding. So all I have to do is write 6/10. And I'd like to be done. It said write it as a fraction, and I did. But I'm not done because of that silly rule that you have to reduce fractions in order for a fraction answer to be done. What am I going to reduce this one by?
2.
2. 3 doesn't go into 10. Okay, for the next one, it's not 6/10 anymore. What should I write first? 6/100. This is why we started with the place value review, so you could actually say the names of these decimals. Okay, same thing. Let's divide by 2 top and bottom. And then the last one, we have 17/100. Anything in common between 17 and 100? No, so we're just done with that one. The fancy words we had were these were relatively prime. It's not that 100 is prime. 100 has lots of factors, but compared to 17, there's nothing to reduce by. Okay, questions about what's on the board?
We're not messing with mixed.
Not yet. We'll do mixed numbers eventually.
Okay, because that would, okay.
Good question. Yeah, we'll work our way up. Okay. There's a little game we could play where you take numbers and try and plug 3 of them in to make something that's true. So let's wait for now. Maybe we'll do that later. That's more an at-home thing. To go the other direction, then we want to take the fraction and treat it as a division problem. To some extent, fractions are like division problems waiting to happen. If I have 1/5, it's like I have something, I'm cutting it into 5 pieces. Whether I eat that pie now or I just get to tomorrow, I'm not quite sure, but it's like the division is waiting to happen. So if I did 1 divided by 5, I'd get 0.2. If I did 3 divided by 8, I did have a question, not an announcement, but a question about syllabus things. If I use my calculator to be quick, I get 0.375. We did the long division last time. When designing the syllabus for this term, I forgot that the people who teach Math 60 like me to have part of what I grade you on being no calculator for some things about this kind of thing and fractions and some other things. And it's awkward to make that part of the final because then you have to do like a little part that's no calculator and turn that in, and I give you the rest of the final and you take out your calculator and it's just blah. Anyone object if I add to the syllabus a no calculator thing to do so that we don't have to use the final to measure the same thing?
So no calculator on finals?
No, calculator, I want the calculator on the finals.
Oh,
So I want to peel that off and make the no calculator part a second thing. So we don't muddle up the final with trying to do 2 things at once. Everyone okay with that?
So how did you get?
Well, I cheated and used the calculator, but if I want to do it long division,
Oh, so we can't use calculator.
yeah, if it helps. The numbers I make are small. If I want to have 8 go into 3.
Part is not the more difficult part.
No, the numbers are small on that,
Yeah.
but it's just kind of awkward to try and measure 2 things at one time. Okay, how do we have 8 go into 3? It doesn't fit. So I have to put a decimal place next to my 3 to make it 3.0. When I put the decimal point there, it goes here also. And then I can say, 8 times 4 is 32. That's not going to work. 8 times 3 is 24. 7 times 8 is 56. 5 times 8 is 40. So there I go.
So for the fractions in this case,
For the fractions,
for the fractions in the case.
for this part, I would be able to do it both ways, because someone might ask you to do this without a calculator.
I'm saying, for the fraction, are we allowed to use a calculator?
For both things we've done today, both directions, be able to do it with or without. So. Okay, sometimes, if you're not allowed to use a calculator, there's a trick to do. So let me show you that. If my denominator is already a factor of 100, I can make it into 100 and then just read it like 400ths. Similar with tens and thousandths and things like that. So let me just make one up. If I have a fraction like, whatever, 2. That's something I can make the denominator either 10 or 100 or 1,000 or 10,000, which is the easiest way to make it one of those. I want to change 500. I want to unreduce it and make it, well, it can't be 10. It's already bigger than 10. It can't be 100. How do I make it 1,000? Times 2. Yeah. So if I do a times 2 top and bottom, then I get 4 over 1,000. And that's just 4 thousandths. Whoops. 0.
You can only do that if it's arbitrary.
I can only do that if my denominator starts out a factor of 10 or 100 or 1,000 or some other power of 10. This is, in general, a stupid shortcut. Almost everywhere in your life, you're allowed to use a calculator. And by the time you've stared at this and say, can I change 500 into something and use the shortcut, then the person next to you has taken out their phone and done this on their calculator. So as shortcuts go, it doesn't get a lot of gold stars, but it might help you understand what's going on. Okay, the process I told you doesn't always work. If we have a repeating decimal, then you can't say its formal name. If 321 goes on forever, it's not 321 thousandths because there's more stuff. So I need a different trick to take a repeating decimal and change it into a fraction. By the way, if you haven't seen at the bar, we write repeating decimals by putting a bar over the part that repeats. If we don't, then if you just saw dot, 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 you wouldn't be sure what's happening. Is it only the 1 that's repeating? Or is it the 2 and the 1 that are wiggling back and forth? Or is it all 3 digits, 321, 321, 321? We're not sure. So people might write something like that, put the bar over whatever is repeating, and that way it's saying, ah, this is the one that I mean. So it's not ambiguous. So if you haven't seen the bar over things, that's what the bar is. Okay, there is a trick to take any repeating decimal and make it a fraction, but you're not responsible for that in Math 20. It's more of a Math 60 level trick. What we do want you to do, though, is just memorize the 3 most common ones that will help you with tests and homework and things like that. So 1/3 is going to be 0.3, repeating all over. Let me make that a straight bar. 2/3 is twice as big, so 0.6 repeating forever. And then 1/6 is 0.16 repeating forever. only 1, 1, lots and lots of 6s. So memorize those both directions, and then you won't run into any trouble when you can't say, what is this? It's not 3/10, it's not 300ths, it's not 33 hundredths, it's not 333 thousandths, because it just keeps going and going and going. It used to be in Bittinger, if you opened your book to the back cover, there were some of these that were given to you as a sort of things to cram on the back cover, but I think it put too many there. Okay, questions about moving back and forth between decimal format and fraction format? You think you're good. Okay, we'll have lots of practice later on. Our last subtopic for fractions is ratios and rates. So for all of our fractions, we're proper fractions, like a cake is cut up into this many pieces and I get so many of them. Lots of fractions don't have that same sense of the bottom number is the total and the top number is how many special ones we care about. So it's also not quite true that fractions and division problems are quite the same. If we were to take 10/5 and try and do division, we would never say, oh, 10 divided by 5, let's reduce that before we divide it. Divide both by 5 and get 2 divided by 1. That looks very strange, right? No one would do that. So fractions are not quite division. And because they're good for things, we have lots of ways to do fraction math, and we want to make some things like fractions. So when we compare numbers is a great one. A package of 24 energy drinks costs $35.99. Do we care how much one drink costs? I'm not sure. Maybe we have to do that division, maybe not. So like Snoopy pretending to be a vulture, we will just lurk and do the division if we need to, and otherwise keep that comparison. Similarly, somebody charges $2,800 to install a 120-foot long fence. Do we care how much per foot? We could do the division, get the price per foot, but maybe we want that, maybe we don't. We're not sure yet. So we call that a ratio. A ratio is a comparison of two numbers, and we usually write them as a fraction. So if we have 10 dentists and 8 of them like a certain breath mint, we can just write 10 over 8. Whoops, 10 over 8. We could also write it as 8 over 10. We're just comparing it, so it's not like we have to have the bigger number on the bottom anymore. It's not like one is necessarily part over whole. In this case it is, but not always. If we had flying 38 miles in 40 minutes, it's not like one of those numbers is a piece of the other. Writing it both as 38 over 40 or 40 over 38. It's not like one is better than the other. Sometimes there really isn't a total unless we do some extra math. So here's a classroom with 4 left-handed people and 16 right-handed people. It doesn't matter which one we write on top. I can look at these numbers and say how many people are in the room, assuming everyone is either right or left-handed, and add them up, 20, but it doesn't give me the 20. So these are ratios. We're comparing things. Maybe we're going to do division, maybe we're not. And it doesn't matter as much if one is part of the other. Okay, let's keep going. I did that already. We can turn it upside down and it's okay. There's the breath minutes. In ratios, it doesn't make sense usually to reduce or unreduce them. If we took the 8 out of 10 dentists interviewed and unreduced it to 80 over 100, then we'd be exaggerating. He didn't actually go interview 100 different dentists. We're making it sound like he did more work than he did. Similarly, if he did interview 100 dentists and it was 80 over 100 in real life, and we reduced it to 8 out of 10, then we're sort of discounting how much effort he put into his surveying. So you can reduce and unreduce ratios. People might ask you to, the textbook will ask you to, but in real life it could be slightly awkward. There are other ways to write ratios. You could write it with the word 2, 8 to 10, instead of a fraction. Or you could use a colon, 8 colon 10. Those you see mostly on like SAT tests and gambling and things like that. Not very much in a math class. For us, the whole point is we want to write them as a fraction because we know how to do certain kinds of arithmetic with fractions. And this way we can do that. Okay, if you open your Bittinger textbook to section 5.1, you would see that the section isn't that exciting because again, all we're doing is writing one number on top of another. You can do this, put one number on another. On problem 21, Bittinger does what I just did and say, write the ratio both ways. First do it with one number on top of the other and then flip it. Which seems a little strange because no one has ever asked you, write this fraction and then turn it upside down for no reason. But you can. In number 23, the textbook asks you to simplify a ratio. We just talked about how that's a little bit unrealistic if there was some real life situation that made these numbers, but we can reduce that. That's fine. The tricky one is number 30. It asks you to simplify a fraction that has a decimal inside it, and we haven't done that yet. So let's do that one together. What's the amount for someone who's looking at it? Which one?
1.8 to 6.2.
4.8, 6.4. Okay. Now the first thing I want to do is not use the word simplify. In some math classes, everything is simplify. You have no idea what the teacher or the book wants when they say simplify. It means too many things. So we're going to just say reduce because that's what we actually want you to do. Okay. If I had whole numbers, I would know what to do. But with the decimals, then I can't do my little thing because there's no divisibility rules with decimals. So how do I make this into something I know how to deal with? I don't want to lose any accuracy. If I rounded it, then
Yeah, just move the decimal.
move the decimal. Yes. So a moment ago, we did this one. We multiplied the top and bottom by the same number and everything was good. Now we're going to do the same thing. If I multiply the top and bottom by something, I can get rid of the decimal. What should I use? 2? No, it's going to be like 12.8. 2 is not a good one.
Is it 10?
10. You can think of it as times 10, like I'm writing, or you could think of it like, let's do 1 decimal point scoot for each of them. Those are just 2 different ways to say the same thing with mathematics. The shortcut for times 10 is scoot the decimal point 1 to the right. So now I have 48 over 64. Yay, now I'm in business. I know what to do with this. How should we start reducing 48 over 64?
By 2.
By 2?
What about by 12?
Oh, because someone said 2 first. So 24, 32. I need to keep going. Why did that scoot? Okay, what now?
5 times 4.
I bet you, well, a 32 won't have 12 go into it.
Did you do 2 again? What? An 8?
Oh,
Right by 4.
4. Okay. Oops, not 4. 3. Okay, now we're looking at it. If you had seen it divided by 16 right away, you could do this very, very efficiently and show off, but that's okay. This works just as well. Okay, questions about this one? So we just saw 2 different things. Let me compare them again, where we were multiplying a fraction by some number top and bottom. 10 would clear the decimal places. If there were more decimal places, if this was a different problem and we had that, what would I do instead? Yeah, multiply by 100, do 2 decimal point scoots. So that was one technique. The other was the occasionally useful shortcut to make a denominator a power of 10 before turning a fraction into a decimal. So different tools for different tricks. Okay, ratios cause people to miss problems on tests because it's too easy to flip things over and get your numbers mixed up. So the solution to that is to include some words. We'll label things. We have 18 green candies and 9 yellow candies, and we'll put the words in there. That way we catch ourselves if we have it flipped upside down and don't just have a bunch of numbers running around on the page. So what we really like are those, and because they're nicer, we give them a new name. So a rate is a ratio in which the numbers have different labels. So a labeled fraction, right? A labeled ratio is a rate. Our favorite rates are the ones where the second number is 1. Has anyone ever gone shopping for ice cream? And this one they label in dollars per pound, and this one they label in dollars per ounce, and this one they label in dollars per whatever quart, and you're not sure which ice cream is cheaper. So we like to compare things, and it's easiest to compare them if the second number is 1. Miles per gallon, dollars per pint, feet per minute, something like that. So those are unit rates, unit meaning 1. So if we have 18 green candies and 9 yellow candies, actually I don't want to do this here, it's too crowded. It's just copy image. I could write it as a rate, 18 greens to 9 yellows. I could write it as a unit rate, and there's 2 ways to do that. Some people like fractions, and they would just treat this as a fraction reducing problem. That's great. Other people like division. They will treat the fraction as a division problem. 18 divided by 9 is 2. Then to keep it a rate, you have to still label it with at least the words looking like a fraction. This is where we get miles per hour or dollars per gallon or things like that. So either of those works fine. Yes, question?
Is it okay if you can still put the denominator under the 2?
Put 2 over 1?
Yeah.
Yeah, you could.
Even if you still with the greens over yellows?
Yeah, you could write this. It's not common, but there's nothing wrong about it as far as the math goes. So the subtle thing is we want to keep the words. Whichever style we do, we want to keep the words because that helps us in the word problems check that we're using the numbers in the right places. We'll get to that later when we actually get to word problems. Okay, your turn for one. So we have 300 pieces. Oops, I can spell. In 90 minutes. How would you turn that into a unit rate?
Divided by 30.
I don't just want to reduce it though. I want to make the denominator all the way to 1, even if that sort of breaks the numerator.
And just divide the numerator by the denominator.
Yes, if I'm the division way of doing things, then I could say, what is 300 divided by 90? And I would get 33.3 repeating pieces per minute. Depending on the context, we could just put a box around that, or we could round it. In this case, do you think we really have a decimal amount of accuracy for jigsaw puzzle solving? Probably not. People aren't that mechanical with their jigsaw puzzle times, right? So it probably makes sense to say, let's round this to pieces per minute. The other method would say, I want that 90 to turn into 1, so I'm going to divide it by 90. If I do something to the top or bottom of a fraction, I have to do it to the other to be fair. So same thing. In both cases, I have a 300 divided by 90. It's just sort of where it's written on the page, whatever makes your brain happier, makes your eyes happier. Okay, questions on this? So far, it seems like an easy day. I'm asking you to write something on top of each other, or I'm asking you to do a division problem. So there we go. Nothing scary yet. Okay, an important thing to note. Whoops, let me shrink this so it fits on one page. Is that when I'm making a comparison, sometimes I want the bigger number and sometimes I want the smaller number. It depends on what choices I made to get the comparison. So in this example, I'm shopping for a fancy hand lotion, maybe a gift for a friend. What do I want? 10 ounces for $5 or 24 ounces for $8? I'm assuming I don't care about which one I get. Just the money. So if we're looking at this as how many ounces we get per dollar, then the bigger number is the better buy. People who would do it this way maybe think about shopping like they're going to a gas station. They're handing someone $1 and they want the most they get for that dollar. Other people say, no, that's backwards. The way my brain works, I want to take the money and divide it by the amount. I want dollars per ounce. If I'm doing that, then the smaller number is the better buy. It's the same answer, right? It's just in one case, it's right because it's bigger. In the other case, it's right because it's smaller. This would be like if I never use coconut flakes. For some reason, I need some coconut flakes. So I'm going to go to the bulk section of the store and go in the bin and get the right amount of coconut flakes, and I want to pay as little as possible for that, for whatever volume it is I need, or weight I need. So both work. One of them will seem natural to you. Just keep track of that. This is mostly a heads up so that if you're working with one of your classmates before class or in a study group, and they happen to pick the other one, then don't freak out and say you're doing it wrong. They're just doing it because that way works too. It's just their brain likes the other method. So, okay, questions about that? We're good. Oh, okay. Again, OER stuff and videos, if that helps you. Is anyone using the videos? Raise your hand. Oh, but okay. There is one of those class participation achievements for finding more videos. So far we're pretty good, but we'll get to topics that don't have as many yet, and you can help everyone. Okay, we talked about decimal point scoots a moment ago. Let's do that more carefully. If I'm multiplying things, let me make this bigger, by powers of 10, that's scooting the decimal. We just said that a moment. So if I multiply by 10, how many scoots would that be? 1. So 1, 2, 3, 4. If I multiply by 100, how many scoots is it? 2. 1, 2. If I multiply by 1,000, how many scoots is it? 3. So when I multiply by powers of 10, I scoot to the right, and for every 0, I do that many scoots.
Is it always on the same direction?
We'll get to that. There's 4 different cases we have to get through. For most Math 20 students, this is boring, but pretty soon we'll get to the part of the review that you're like, getting complicated. Okay. If we divide, well, dividing is the opposite of multiplying, so guess what happens? It goes the other way. We do the opposite, right? If I divide by 10, I'm going to scoot once in that direction. If I divide by 100, or if I divide by 1,000, 3, because you know the pattern or you're reading down below. Okay, so far so good. Multiplying things get bigger. That kind of makes sense. Dividing things get smaller. Number of zeros is number of scoots. Ready for the next one? Oh, good. Now we're going to multiply not by powers of 10, 100,000, but by powers of 1/10. So we're multiplying by smaller things. And remember that multiplying, we usually can use the word of for in word problems. So if I have a tenth of something, is it going to get bigger or smaller?
Smaller.
Smaller, right? A tenth of a pie is smaller than a whole pie. If I have 100, it's even smaller still. If I have 1,000th of a pie, that's like a crumb. That's just tiny, right? So which direction are these going to go?
Left.
Yeah, these are the smaller ones. If I multiply by 1/10, then I scoot there. And now we get to sort of have this vicious argument. Some people will say, I'm scooting once because there's a 0 here, so we're scooting once for 1 0. They want it to match what we just did before. Other people will say, no, I wouldn't normally write that 0 there. At home, I just write 0.1. So they're counting not zeros, but how many digits you have after the decimal point. Whatever makes sense to your brain. Don't arm wrestle your study partners because they're doing this one. Okay, anyway, if I have not 1/10, but 100th, how many scoots will I do? 2. Whatever makes sense about why that number is 2. And there you go. And for the next one, we'd scoot 3. So, compared to our first case, multiplying by 10, 100, 1,000 going to the right, division made it backwards, or making these decimals made it backwards. Okay, I need a brave volunteer who can walk. Yeah, okay, so come up here. You're going to stand at this bar facing positive and take 3 steps. Ta-da! Okay, go back and reset. What's one way he can show us -3? 3 steps back. Okay, 3 steps back. Ta-da! Okay, reset. What's another way he can show us -3?
Squat down.
No.
Point left.
He can, yeah, turn around and take 3 steps, right? So do that. Turn around and take 3 steps. Ta-da! Okay, one last time, then you're done being a pedestrian. So do both. Start facing positive. Now show us 2 negatives. So turn around and backward steps. Where does he wind up? Positive. Everyone see now why negative and negative make positive? Hey, okay, thank you. Great. So, if I do both of those things that were negative, I'm doing division instead of multiplying, and I'm using the little decimals instead of the 10, 100,000, what's going to happen? It's going to go back the positive way. What was your name, by the way? Kate. Okay, just like Kate. Thank you. So 1, oops, artwork fail. 1, 2, 3. Okay. And now you're all experts at decimal scoops. And I need to remember to take attendance, and then we'll maybe get out on time. Okay, I'm going to pause the recording because we don't need to actually